Okay, people, so this is your first revision video. This video is going to be on study area 1. I won't be doing a video on study area number 2 because we did quite a bit of work on that during the SAT. Okay, so it'll be study area 1 and study area 2. So let's start. Okay, let's start with something simple first. Let's say we have a substance like this. Okay, now this, if you look carefully, this looks like it is CnH2n plus 2, right? So this is basically an alkane, right? It's an alkane. And in the petroleum industry, what happens is when you dig petrol from the ground, you get an alkane. Okay, they're all mixtures of alkanes. So when you have an alkane which is very big, it's quite useless. So what we're going to do is we're going to break this down. We're going to break this down into a smaller form, and this process is called cracking. Okay, cracking does not have oxygen, so no oxygen. All right, so it only uses high temperature and high pressure. Okay, so anyhow, during cracking you get products. You usually get an alkane, okay, or and then you get an alkene usually. All right, or you can also get alkane. All right, you can get okay, let me correct myself here. You can get you can get an alkene, and you can get hydrogen, just hydrogen. That's also a possibility. Okay, so there are many possibilities. So to make things simple, in this case what I'm going to do is I'm going to use one example here. So I'm going to get C10H22, and then I'm going to get C10H20. so this is decane, okay, and this is decene. All right, so you get an alkane and alkene. So the important thing here is the number of carbons on the right and the number of carbons on the left must be the same. The number of hydrogens on the left and the number of hydrogens on the right must be the same. That's all you got to make sure. So there are many possibilities. So one possibility could also be something like this, C12H26. Okay, and then you might get like 2 moles of C4H8, like you get 2 moles of butene, for example. Okay, you get this. So there's so many possibilities, right? So there is not just one possibility. So when you get a question like this in the exam, you just got to make sure that the number of carbons and hydrogens on left and right is the same. So what I'm going to do is, for the rest of the story, I'm going to use this guy as our example. So let's move on. So we have alkanes, and then let's say we have an alkene, right? So in this case, we are dealing with an alkene with a formula of C4H8. So if you look at it, right, this is actually, this is actually CnH2n. So this is an alkene, all right, alkene. So alkenes, the N value always starts with 2, 3, and then it goes on, right? So an alkene has a double bond. All right, it has a double bond. So for this guy, let's say we want to draw, there's so many possibilities here. Okay, so let's say we want to draw isomers. All right, so isomers, there are 2 types of isomers. One is structural isomers, and the other ones are geometric isomers. Okay, geometric isomers are, okay, I'll tell you in a while. Geometric isomers are like, oops, what happened here? Geometric isomers are like the E and Z. Okay, E and Z. So these are the E, Z, and trans. Cis and trans are, they are the same. So cis and trans is also the same. Okay, also the same. Okay, so what we're going to do is, for the sake of discussion, we talk about structural isomers. So in this case, okay, so in this case we are dealing with C4H8, right? So what are the structures that we can draw? So we can draw a double bond in the first place. All right, we can draw a double bond in the first place. So we just got to make sure the number of carbons and hydrogens are the same. So this will be but 1 in. All right, then we can draw the double bond in the second place. We can draw it in the second place. This becomes but 2 in. All right, so the numbering goes with 1, 2, 3, 4, 1, 2, 3, 4. And then the other thing you can do now is you can make it into a propene. And then you can put 1 CH3 here. All right, you can put a CH3 here, and then you get what is the name for this guy? So the numbering will go with 1, 2, 3. So in this case, this guy is going to be called methyl propene. Okay, so you don't have to mention number 2, because it's, if for this guy, methyl can only be at number 2, it cannot be at number 1. Methyl cannot be at number 2, it has to be a number, what am I saying, it cannot be a number 1, it must be a number 2. All right, methyl propene. Then, okay, so this is, when I did this question in class, one of my students corrected me, and I said, hey, there are 2 more isomers, so there's 1 more isomer for this. Then it reminded me, I think, if Tekchi, you're watching this, Tekchi, all right, so Tekchi, okay, there's 1 E only in his name, oops. Okay, Tekchi, I just made you famous. All right. So Tekchi said, hey, why can't we draw this? Then I remember, oh, shit, yeah, you can. So let's do this. So with this formula, we can also draw this. This is another one, right? Yeah, so this one, this is cyclobutane. Aha, cyclobutane. So this is another one. So there are already 4 here. Then what we can do is we can go crazy and we can just draw this now. So we can draw, make sure all carbons have 4 bonds. Okay. And then we can put another CH3 here. All right. And again, making sure carbon has 4 bonds. There we go. So this becomes like methyl cyclopentane. You don't need to know the name. Okay. So here you go. These are all the different structural isomers for this compound. Then if we are going to be talking about, this geometric isomers, right? So what we're going to do is we're going to focus on this guy here. Okay, we're going to focus on this guy here. So I'm going to bring him out again. So when we focus on him, right? So what we're going to do is, let's look at this person. Okay, so I'm going to do 2 things at the same time now. So you see here, what can happen is, okay, let me do the colors. Hydrogen. Okay, let's say this is red. Hydrogen, 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 right? Hydrogen, hydrogen, hydrogen. So there are 2 things that can happen here. One, I'm going to talk to you about polymerization. Another one, I'm going to talk to you about cis and trans. So when you need to draw cis and trans isomerism, what I want you to do is, what I told you before in class, I want you to focus on this guy here. Just focus on that and draw him back again. Let's draw this again and draw it again here. Okay. So then what we're going to do is we're going to take the hydrogen. Okay. We're going to take this hydrogen and this hydrogen. What we're going to do is we are going to draw them like that. Okay. And then we're going to take the methyl. We're going to take these groups and then we're going to stick them down. Right. So we just draw them like that. CH3. You can draw them like this. You don't have to show the whole structure. Ta-da. And then for this part, you keep the left-hand side the same. Don't change the left-hand side. You change the right-hand side. Okay. You change the right-hand side. So here, if you look at it, right, we always use atomic numbers, easier. The atomic number here is 1. Carbon's atomic number is 6. This is 1. This is 6. So if you look here, these 2 are facing each other. 1 and 1 is facing together. 6 and 6 is facing together, right? So this is what we call we call this cis. But 2 in. And then some of you will say, I don't want to call this cis. I want to call this Z. I want to call this Z, but 2 in. Yeah, you can do that as well. Okay, you can do that as well. You can call this Z, but 2 in. So if this is Z, then what happens here is, okay, this is 6, this is 1, this is 1, this is 6. So you see the numbers opposite side are facing each other. Big facing small, okay? So this is called trans, okay? This is called trans but 2 in. Or this is called E, entangled but 2 in, okay? So that's how you do it. But just to digress a little bit. So let's say, for example, you had something like this. Okay, let's say this was the double bond. Let's say you had double bond here. And then let's say you had, let's say you had a H and then you had a Cl and then you had a CH3 here. And then let's say you had, let's say you had a bromine and then and then you had okay, life is getting complicated now. Let's say you had fluorine. Okay, let's say you had something like this. Okay, let's say you had something like this. Wow. Okay, what we're going to do again is when we want to draw cis and trans, let's say you got something complicated like this, no problem, just focus on this part. Okay, so let's draw him out again. And since you have one bromine, you put a bromine up here, and then you put a fluorine down here. And on this side, you have, okay, maybe I made a mistake here. I should have just removed this person here. Remove him. Okay, let's remove him. Let's make things simple. Let's bring this closer. Okay, done. So what we're going to do is we're going to put a chlorine up there, and then we're going to put a CH3 down here. And on this side, what I'm going to do is I'm going to put the CH3 up here, and then I'm going to put the chlorine down here. All right? Okay. So here we go. Fluorine. So what you guys need to do is you just need to look at the atomic numbers. Go to the periodic table. Look at atomic numbers. Okay, Damien, are you listening to this? Damien, this is for you. Okay, but I won't tell which Damien, but we all know which Damien this is. We look at the atomic numbers, and this atomic number is 35, and this is 17, and this is 9, and this is 6. If I got this wrong, just keep quiet. But anyhow, that's what it is. So what we're going to do is if you divide this half here, you realize 35 is, okay, sorry, let me go back in time again. So what you got to do is you decide between these two numbers which one is bigger. 35 is bigger, this is 2. 17 is bigger, this is 1, and this 6 is smaller, this is 2. Okay, so at this point I want you to notice that 1 is facing 1 and 2 is facing 2. 1 facing 1, 2 facing 2. So this is going to be what? This is 1 and 1 facing each other. This is going to be Z, whatever this guy is. So if that's the case, this was 35, this was 9, and this was 6, and this was 17. Again, so what we have decided just now was what this number is bigger than this, and this number is smaller than this, right? So now you realize, big facing small, small facing big. This is called E, entangent. Okay, E whatever. So I hope you know this. If you don't know this, please watch this video 10 times more. Okay, all right, so we're going to come back to this again. So this would be your geometric isomers. Your cis and trans will be your geometric isomers. Okay, now coming back to polymerization, totally unrelated. So let's say I'm going to use these two examples, right, to do polymerization. So let's say whenever you have double bond, you undergo addition polymerization. Okay, that can be a Z there if you want to, but whatever it is, addition polymerization. Let's say you have been given something like this. You've been given a butene. Okay, you've been given a butene, but 1 in, let's say, and then in that question you have been asked to draw the addition polymer. Okay, you've been asked to draw the addition polymer. Or let's say you've been given but 2 in. Okay, let's say you've been given but 2 in. You've been given but 2 in to draw the addition polymer, right? So either but 1 in or but 2 in. So whichever way, whenever you're given somebody with a double bond, what you do is, again, very, very easy. You just focus on this part. So what we're going to do is we are going to look at that. We're going to draw the double bond back again. Okay. Then what you do, this hydrogen here, and this hydrogen here, we just put them up and down. Okay, up, down. Okay, and then this hydrogen here, I think I just complicated my life a little bit. Oh yeah, and sorry, that hydrogen we're going to put up there, and then this entire group here we're going to put down here, right? So we're going to put it down here. So it's going to be CH2 and then CH3. Got it? All right, did I get this right? Yep, I did. Okay, so we're going to put it down there. Then what you do is you erase this off, and then you draw one line out here, bracket, ta-da, done. That's it. And then what you can do is you put an N here. Okay, you put an N here, and then you put an arrow, and then boom, there you have your this is called your This is called your repeating unit. Okay, repeating unit. All right. So for this guy, for butene, right? For butene, same thing. We're going to focus on the double bond part. So when we focus on the double bond part, okay, so we're going to draw the double bond, right? So we're going to put that one hydrogen on top, the other hydrogen on top here. We put this CH3 down here, and we put this CH3 down here. Okay. So once that is done, what we're going to do is we can erase this off. And then what you're going to do is you're going to put one line here, you're going to put one line here, close bracket, put an N here, ta-da, done. And then you put an arrow, you put an N here, and that's it. So this is your repeating unit. Okay. So for addition polymerization, that is how you do this. All right. That is how you do this. And then, before I forget, when you talk about cis and trans isomerism, right? Cis and trans isomerism, when you talk about this, I want you to know that if you have the same group on either side, you have hydrogen, or you have methyl, or you have whatever group, let's say you have bromine and you have bromine here, you cannot have cis and trans isomerism. Tak boleh. Okay? They must be different. All right? They must be different on the same side. Different side, not so bad. Same side, you cannot have cis and trans isomerism. Okay, so that's another thing you got to say. So you cannot have, I repeat, you cannot have the same groups. You cannot have a hydrogen, or methyl, or bromine, or whatever on the same side for it to have. So if you have that, you cannot have cis and trans. Are we okay with this? Anyway, I can't wait for your response. I'll just assume yes. Okay, let's go on with this. Okay, so we are done with this part. So I've covered two things here, right? And so, addition polymerization and then isomerism. Okay, let's go to reactions. So I'm going to use but1-ene for the examples. Okay, so I'm going to use but1-ene. Okay, so when we have but1-ene, right? So there are many reactions that can happen. Like for example, okay, let's say we have but1-ene. We have but1-ene here, right? Okay, so there are many reactions that can happen. We can add something like bromine, okay, or we can add things like chlorine, or we can add things like iodine. This entire reaction is called, okay, what is it called? It's called addition, but you can call this halogenation, okay, halogenation. But these are all addition reactions. So in the exam, if you ask what type of reaction is this, if you say addition, good enough. If you say halogenation, even smarter. But if you want to be sounding more intelligent, you can call this bromination, chlorination, iodination. Okay? But please don't text and ask me, so what you said, bromination, what? Let it be. It's addition, or you can just call it halogenation. All of these reactions are done at room temperature and pressure, okay, RTP, at RTP. You can just write RTP, no need to write anything else. So what will happen is addition reactions will happen, okay, addition reactions will happen. So while we're talking about this, I wanted to tell you that every time there is one double bond, right, whenever there's one double bond, there is always one replacement. So for example, let's say we do iodine, okay, we do iodine, okay. So when you do iodine, for every double bond, let me finish drawing this. This is the boring part. Okay, for every iodine, one iodine will come here and one iodine will come here. All right? Whether it's iodine or hydrogen or chlorine or bromine, it'll be like that. Okay, it'll be like that. So it'll add on over there. Oh, by the way, since I talked about hydrogen, so if we use hydrogen, and hydrogen is usually used at 180 degrees Celsius and using a catalyst platinum, usually platinum or nickel. This reaction is called hydrogenation. Okay, hydrogenation. This is usually done to convert something which is unsaturated to saturated. That means something with double bond into something that doesn't have double bond. Okay, so if you want to convert vegetable oils into solid margarine, you use this reaction, hydrogenation. Anyway, back to iodine again. So I want you to notice this, right? For every 1 mole of alkene, you need 1 iodine. So, but in simple terms, what I'm trying to tell you here is this. For every one iodine, for every one double bond, okay, for every one double bond, you need 1 mole iodine. You understand that? You need 1 mole iodine, you need 1 mole bromine, you need 1 mole chlorine, and 1 mole hydrogen. Please remember that. Now I'm going to digress again. Why am I talking about this? But because some of you have this little problem. You like, you don't know, sir, how do I do this? How do I do this? You send me all kind of messages, but let me look at somebody who sent me this message. Where is this? Okay, so let's say, like, for example, okay, so there was this one question that you asked me, but I'll talk about this in a while. So let's say you're given a hydrocarbon like this. Okay, you're given a hydrocarbon like C17H 31COOH, and then this is called fatty acid. This is like body shaming, right? Fatty acid. This is called fatty acid because it is derived from fat. I want all of y'all to know that all fatty acids, because this is on topic of triglyceride, all fatty acids are carboxylic acid. Okay, all fatty acids are carboxylic acids. That's what they are. All carboxylic acids have a general formula of CnH2n plus 1 COOH. Okay, so N can be what? N can be starting from 0, 1, 2, and so on. It's carboxylic acid. So my friends, when N equals to 17, let's plug it into the formula. What you get? C17, H17 times 2, 34. 34 plus 1 is 35, COOH. Now pay very close attention. You look at this, right? This is 31, this is 35. 35 hydrogens minus 31 hydrogens is what? 4 hydrogens. Okay, 4 hydrogens. What does 4 hydrogens mean? That means 4 hydrogens are missing, right? They're supposed to be H35, but now it's only H31. 4 hydrogens are missing. What does that mean? You see, every time there is a double bond, right? What happens? If you want to undouble bond this, or you want to saturate this, you add hydrogen, right? Am I right? You add hydrogen. How many hydrogens are you adding? 1 mole of hydrogen molecule. 1 mole of hydrogen. So this is 2 hydrogens, right? So 2 hydrogens for every 1 double bond. So 4 hydrogen means in this molecule there are 2 double bonds. Is that clear? There are 2 double bonds. That's what it means. It means 2 double bonds, right? If 6 hydrogens are missing, that means 3 double bonds. Is 8 hydrogens are missing, that means 4 double bonds. Please know that. So for every double bond, you need either 1 hydrogen. Where am I? Okay. Here. For every double bond, you either need 1 bromine or 1 chlorine or 1 iodine or 1 hydrogen. All right. So if there are 2 double bonds, you need 2 bromine, 2 chlorine, 2 hydrogens. That's it. That's how it works. All right. That's how it works. So there was one question here that somebody sent to me, and the question reads something like this. Okay. It says, hey, 0.1 mole fatty acid, all right, reacts with 50.76 grams iodine. Okay, so they ask you what is the fatty acid. So for this question, all you got to do is you got to divide this with the molar mass of iodine and find out how many moles this is. So 0.1 mole, and then you compare with this. I think you get 0.2 here. I think lah. I could be wrong. You get 0.2 moles. So the ratio is for every one of this, you need 2 of this, right? You need 2 iodines. 2 iodines. That means how many hydrogens are missing? If the ratio is 0.2, how many iodines are missing? Sorry, how many double bonds? All together here is actually 4 iodines, right? So 2 iodines is 1 double bond. So it's another 2 iodines is another double bond. So how many double bonds? 4 double bonds. So you're looking for somebody with 4 double bonds. So the answer to this question was C, what I just did here just now. Okay, so please, that's how you do this type of questions. All right. Okay, so let's go back in time again. So this reaction is called hydrogenation. So then what are the other reactions that can happen? Okay, now the other reactions that can happen is, so hydrogenation, and then, okay, hydration. The other reaction is hydration. Okay, hydration. Now hydration can happen 2 ways. one is one hydration is done at concentrated sulfuric acid. You use concentrated sulfuric acid, okay? And you know sulfuric acid is aqueous. These type of reactions are done small scale. Small scale meaning in school lab lah, kichi you can do in a test tube. But in industry what we do is we use 60 atmospheres. When I say we use, it makes it sound like I'm doing it. No, I'm not. 300 degrees Celsius, and they use a catalyst called phosphoric acid. Okay, so this is what happens at so of course at 300 degrees water is no longer liquid, it's gas. Okay, so this is done at that temperature to produce, okay, what do you produce? So let's say listen very carefully, okay? So let's say you have this guy. Okay, now you got to listen carefully here. Okay, so let's say you have this same person again, okay? But 1 in. So what will happen is there are two things that can happen because you're adding water. So this reaction is called hydration. It's also addition. You call this addition also correct, but it's called hydration to be more specific. So what will happen here is, okay, so I'm going to draw that, right? I'm going to draw this. So what will happen is, you see, the hydrogen can add over here and the hydroxide adds over here. That's one possibility. Okay, one possibility. A second possibility is, okay, let's do this again. Second possibility is the OH can add over here and the H can add over here. These are the two possibilities, you see, because the double bond is at the edge there, right? So same thing with all alkenes. This is possible. Okay, this is possible. And it's the same thing for a reaction. If you are adding, let's say there's another reaction exactly like this, so where you add hydrogen chloride, okay, you add hydrogen chloride, or you add hydrogen bromide, or you add hydrogen iodide. These reactions are done also at room temperature and pressure. Okay, you will get the same product. Your hydrogen can be on one side, so which means that instead of hydroxide here, you can add a chlorine here, or a bromine here, or a iodine here. Okay, so that's what I'm saying lah. It can be this side or it could be this side. So please remember, there's possibilities. It can be. So here, my friends, you get something called a secondary alcohol. If you don't know what secondary alcohol is, please go and watch my videos. This is called a secondary alcohol. Right, secondary alcohol. And if the OH is the first place, this is called a primary alcohol. All right, a primary alcohol. So you get a secondary alcohol and you get a primary alcohol. So what happens with a primary alcohol? A primary alcohol can be oxidized, and then you can become and it'll become an aldehyde, and then from an aldehyde becomes a carboxylic acid. Secondary alcohol becomes a ketone only. Same thing if you decide to do this, right? So I'm going to take an example here. So let's say this video is becoming longer than I wanted it to become. So let's say we deal with this guy. Okay, let's say we deal with this guy. So what we're going to do now is we are going to add a, let's say HBr. Let's say HBr. This is done at room temperature and pressure. So I told you just now, you get two different products. Okay, you get two different products. Okay. So you can either add the bromine over here, or you add the bromine over here. Okay, and then the rest of it is all hydrogens. Right, all the hydrogens. So the hydrogen is added here. In this case, the hydrogen is added here. Okay, so we get this. So we get what do we get? We get one bromobutane. Okay, we get one bromobutane and two bromobutane. So this is called one bromobutane, and this is two bromobutane. Okay, so we get that. Now what happens is you can carry out this reaction. You can react this whole thing with potassium hydroxide aqueous, and alkali, right? You can boil this. Same here. You can boil this with potassium hydroxide, alkali, boil. You can also use sodium hydroxide. Does not matter. So what will happen now is you will get what? You will get Okay, so this guy is then replaced with an OH. Okay, so you end up getting a primary alcohol there, and in this case you end up getting a secondary alcohol. Secondary alcohol. So you get primary alcohol, secondary alcohol. So this is exactly what happens. This is exactly what happens when you are doing, when you have an alkane and it reacts with chlorine under halogenation or substitution reaction with sunlight. This is what also happens, right? So I'm just going to digress a little bit. Digress again. So let's look at this guy here. So in 2-bromobutane, I hope you notice that there is something called a chiral center. This is a chiral center. That's a chiral center, right? Because that carbon is attached to 4 different groups. So let's bring this in a totally new space here. Okay, let's talk about this. So I'm trying to cover as much as I can in this one video, okay? Okay, so you see here? Okay, so 2-bromobutane, right? This is a chiral center because I want you to notice that this carbon is attached to 4 different groups, okay? What are those 4 different groups? This is the first group, this is the second group, this is the third group, and I'm running out of colors. This is the other group. So there are 4 different groups, okay? There are 4 different groups. Let me change color, okay? The same color. 4 different groups. You see this? So that's a chiral center. So the next question that you usually get will say, draw the RNS configuration. Draw the RNS configuration. So to draw the RNS configuration, what we need to do is we again need to assign the atomic numbers. Atomic numbers, Damien. So this is, bromine is 35. Hydrogen is 1. Carbon is 6. This carbon is 6. So first round, you got to see which number is the biggest. So the biggest is bromine, so this becomes number 1. The smallest is hydrogen, this becomes number 4. Okay. Then the next biggest number is 6. There are 2 6s here. Then the next biggest number after that is another 6. But on this side, the biggest number is 1 or 1 or 1, whichever way. So what happens is this entire group here, this entire group becomes priority number 2, and this becomes priority number 3. So if you are going to draw this, this is what I've told you a million times, literally a million times I've told you this. And if you still can't get this, just forget about it. Don't worry, just relax, I watch TV, you'll be happy. What you're going to do is you're going to put bromine right at the top here. Highest priority at the top. Then the lowest priority, you're going to draw dash lines like this and then put that guy far away from you. If you don't want to do that on the left hand side, you can also do it on the right hand side. Up to you. You can do it this way or that way, okay? Okay, so since I'm left-handed, I'll do it on the left hand side. Okay. Then next, what you're going to do is you're going to draw a thick line this way. Okay, this way. Now, some of you, again, are going to be thinking, sir, can I draw the thick line this side? Can or not? Yeah, you can. Okay, let's say we draw it this way now. Okay, we draw this way. And then another thin line this way. That's it. So, let's say you've been asked to draw R. R means rectus. You've been asked to draw R. So, which means that the second priority should be here, CH2. CH3, and then this will be your CH3. Ta-da, because you're viewing it from here, so you're going this way. Number 1, number 2. This is R, rectus. Okay, but let's say the question says, please draw S. Please draw S. Please draw S. Okay, so then very simple. If you ask to draw S, then you put the CH3 here, and you put the CH2, and then CH3 here. However you want to draw this, is up to you lah. It's up to you whether if you want to do it this way, C2H5 also can. Does not matter. So now it goes from this way and then this way. So it goes this direction. Nobody cares about the hydrogen, all right? That's it. That would be what? That would be S, sinister. So sometimes in the exam questions, you might get some silly questions like this. Okay, I just saw this one question, so I thought I'll use this. So there's a bromine here, and then there's a dash line, dash, 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 dash. Who cares? The dash basically means it's far away from you. And then there's a chlorine here, and then there's one solid line like this, which has got CH2OH. So now they ask you to, hey, they ask you to figure out, is this R or is this S? Okay, sorry, that's not hydrogen. I'm sorry. This is not hydrogen, this is chlorine. Okay, this is chlorine. So they ask you to draw this out. What is this? So basically, just for the fun of it, let's work the priority. This 35, this is 17, this is 6, this is 6, and then next to this is 8. Okay, so in terms of priority, this is priority number 1, this is priority number 2, this is priority number 3, and the smallest number here is priority number 4. So you see in this example, right, there is no hydrogen at all. Do not have hydrogen. There is no hydrogen. So the CH3 automatically becomes the lowest priority. So what we're going to be doing is we always put our eyeball here and we look this way. This looks a bit perverted, but anyway, you look between 2 and 3. So you see the numbers are going this way, 1, 2, and then it's going 3, right? Is it clockwise or anti-clockwise? It's going anti-clockwise. So this, my friends, is S whatever this guy is, okay? So this is S, sinister, all right? This is sinister. Got it? Okay. So what is the name for this compound? Let's for the fun of it do this. So it goes from here, it goes this way. So it's basically C. Okay, there's an OH here, and then there's a C here which was attached to this bromine, which is also attached to this chlorine, and then there's a CH3 here. So what is this guy called? What is this guy called? This is obviously an alcohol, right? Is this an alcohol? An alcohol with 3 carbons. So this is going to be 1, 2, 3. So this is going to be propanol. Okay, this is going to be propanol. So it's going to be propan 1-ol. So this is going to be propan 1-ol. And then at number 2, there's a chloro and bromo. So this is going to be 2 bromo, alphabetical, dash 3 chloro. Okay, and then so then S. So the answer is going to be S2 bromo 2 chloro propan 1-ol. Okay. Oh, sorry. What did I just do? This is also 2. Sorry, 2 chloropropan 1-ol. Got it? Okay, let's go back again. Let's go back here again. Okay, so now we have, coming back to this alcohol, I want to finish up this video. Okay, so now we've already come to get our primary alcohol, secondary alcohol. So now you'll be asked to write the oxidation reactions. Okay. When you do oxidation reactions, you use 2 types of oxidizing agent. You use potassium dichromate, acidified, or you use potassium manganate, acidified. These are often written like this, potassium dichromate, like this, or they are written like this. Okay, they are written like this, or they are written like this. Okay, that's how they are written. So this one, the color goes from orange to green. This one goes from purple to basically colorless. Okay, purple to colorless. That's what happens. All right. So during the oxidation process, these 2 half equations you can get from the SRP table. Okay, you can get it from the SRP table. So how do we write? Okay, so so these 2 reactions, look at the SRP table, right? Cr2O7, 14 hydrogen ions plus 6 electrons, you get 2 Cr3 plus 7H2O, and then you get MnO4 minus plus 8H plus 5 electrons, you get Mn2 plus 4H2O. These 2 are from the SRP table. But for a primary alcohol, when we write the redox equation, so many of you ask me, sir, when I write the redox reaction, can I write it this way? Can I write it? No, you must write it this way, the way I'm showing you now. So a primary alcohol can be oxidized to become a aldehyde. Okay, becomes an aldehyde initially. So if, let's say, the question does not mention excess oxidizing agent or less oxidizing, does not mention anything, then it's up to you, whether up to aldehyde or carboxylic acid. It's totally up to you. So in this case, when you balance this equation, it'll be 2 hydrogens plus 2 electrons. That's how you balance the equation. Okay, that's how you balance the equation. But if the question does not mention whether it is sufficient oxidizing agent or limited oxidizing agent, then what happens is the primary alcohol gets oxidized directly to a carboxylic acid. Okay, it becomes a carboxylic acid. And if it becomes directly carboxylic acid, you balance the equation, you will get like this. That means from here to here, like this. Or if it's from here to here, it's aldehyde lah. If it's aldehyde, then it's 2 hydrogen plus 2 electrons. But if it's directly to carboxylic acid, then it is if it's directly from primary alcohol to carboxylic acid, then it's 4 hydrogen plus 4 electrons. That's how you balance the equation. Okay. So usually what happens is if the question does not mention it to you, then this is what you assume. You can assume whether it's depending on the question, you can assume it becomes an aldehyde or it becomes a carboxylic acid. But the question will kind of guide you and tell you which one it goes to. All right. Then what happens is if you get aldehyde, after you get an aldehyde, you add some more oxidizing agent. Let's say you add more oxidizing agent. Then from here, then what can happen is you can get your carboxylic acid. From here, you can get carboxylic. The same thing, you get the same thing, and then add another 2 electrons and 2 hydrogens. Okay, so it can be step by step or completely. All right. Meanwhile, if you're dealing with a secondary alcohol, what will happen is a secondary alcohol will become a ketone. All right. That's what happens to a secondary alcohol. It becomes a ketone only. Meanwhile, a tertiary alcohol does not undergo any type of oxidation. No oxidation for tertiary alcohols. All right, so up to here we have all, basically I've covered a few things with you. So here you will get your primary alcohol, secondary alcohol, tertiary alcohols. What else am I missing out? Am I missing out anything else that I need to tell you? I think that should be more or less it, isn't it? Let me see, because I saw a question here. Okay. There was this one question here which... okay, I'm going to do this one question and then after that we'll stop. Okay. So the question started off with a little, like a box here. There's an A here and then it says Cr2O7. Okay. Like this. And then this is 2-methyl propanoic acid, and then it goes like this, and then this is C4H8. Okay, and then there's water here, and then here it says polymerization. Okay, this is what I did just now lah, so you get B, right? So polymerization, please remember, I already taught you how to do this just now. So now what we have to do, they ask what's the formula for A, right? So you see 2-methyl propanoic acid. So let's drop this guy out. Propanoic acid, 1, 2, 3. So this is the propanoic acid, 2-methyl. So there's a methyl here. In fact, they don't have to tell you 2-methyl propanoic acid. Okay. Actually, this word is quite redundant. No need to tell you. Because methyl propanoic acid, there is only one way. Before he became methyl propanoic acid, who was he? Before he became this person, who was he? So before he became this... Okay, so he could have been an aldehyde. Okay, but obviously they're not talking about aldehyde because from here, you see here they added water. So this must be an alcohol. So they're going before the aldehyde. So before the aldehyde, who was he? Before the aldehyde, he was known as this guy. He was propan-1-ol. Get it? Okay. So because from primary alcohol you become an aldehyde, then you become carboxylic acid. So sorry, there's another CH3 here. Okay. So you work backwards. Okay. So because from here is adding water, you get an alcohol. All right, people. That's my first video for you, and I hope I didn't miss out much. I think more or less there lah. We are more or less there already. Okay, I'll stop here. Then I'll cover the rest of you study area 1 in my next video.